Why do data type sizes matter in embedded C programming? Imagine building a tiny robot that needs to do a specific task. Every bit of memory and processing power counts. Now, think about how choosing the right data type size can make or break your project. In embedded C programming, understanding data type sizes is essential. It affects how much memory your variables take up, how fast your code runs, and whether your data is accurate. In embedded systems, memory is often very limited. A microcontroller might have only a few kilobytes of RAM and a small amount of flash storage. If you use a data type that is larger than needed, you waste precious memory. For example, a character usually takes 1 byte of memory. It can hold values from -128 to +127 if signed, or from 0 to 255 if unsigned. Using an integer that takes 2 or 4 bytes for a number that only needs 1 byte wastes space. That extra space could be used for other important data. Processor architecture also plays a big role. Some microcontrollers are 8-bit, 16-bit, or 32-bit. The size of data types often depends on this architecture. If you use a 16-bit integer on a 16-bit microcontroller, your code runs faster because it matches the processor's natural word size. But if you use a larger data type than the processor can handle efficiently, your code might slow down or requiring extra instructions to process the data. This can make your program less responsive and more power-hungry. Data type sizes also influence how variables are stored and manipulated in memory and registers. Registers are small storage locations inside the processor that hold data during calculations. If your data type is too large or too small, it can cause errors or make hardware control difficult. Using fixed width types like uint8t4 8-bit unsigned integers or int16t4 16-bit signed integers ensures your program behaves consistently across different platforms. This consistency is especially important when controlling hardware or communicating with other devices. Overflow and underflow are other concerns. If a variable's size is too small, it can wrap around when it reaches its maximum value. For example, if an 8-bit unsigned variable holds 255 and you add 1, it wraps back to 0. This can cause bugs in your system, especially when dealing with sensors or actuators. Preventing this requires choosing the right data type size for the expected range of values. To sum up, data type sizes matter because they directly impact memory use, processing speed, data accuracy, and hardware control. Using the correct size helps your embedded system run smoothly, efficiently, and reliably. Managing data types carefully is a key part of writing good embedded C code that makes your projects work as intended.